is using normal distribution. And it tells us that we have the grade for an economics exam, and there's 300 people, and this is what they actually scored. But it tells you that the grades are normally distributed with a mean of 65% and a standard deviation of 7.5, and therefore we should complete the expected frequency table. So we're going to go to our normal distribution, and we always use normal CDF, it's continuous data. And the first one is the lower bound of 0 and the upper bound of 50, but that's been done for us. So we want to move on to the second one, which is a lower bound of 50 and an upper bound of 60. The mean, we're told, is 65%. You could either write it as 0.65 or 65, and the standard deviation is 7.5. And again, you can write it either way, but just make sure that they're the same. And that gives me a value of 22.9 or 0.229. And then we're going to repeat that again. So an easy way of doing that is just to copy and paste, but this time we want it to go from 60 up to 70. And we can see there we have 495 to 3 significant figures. Now the reason I've written them under my table rather than on my table is because that's the probability, but we know that we had 300 people, so we need to multiply those numbers by 300, and that's what gives me the expected number here of what or how many students would have achieved each of those grades. So that's the first part. So it's the normal CDF and then multiplying the answer by 300. And then the second part, part B, is to write down the degrees of freedom. Now the degrees of freedom is how many columns or how many rows you've got minus 1. It's the amount of information you need to find out a missing number, given that it's the amount of information. So you can only have one piece missing there if you had the total. It's given that you've got the total in order to find any missing information. So this is going to be 5 minus 1, and therefore 4. And then we're going to use a goodness of fit test with a 5% significance level in order to see if it fits the normal distribution. So anytime you are doing any sort of statistical test, you should know that the first thing is to write down your hypothesis. So the first one is that the information or the number of students, however you want to phrase it, follows a normal distribution. And then the second one, the alternate, is that the number of students does not follow a normal distribution. Now, obviously, in the exam, you write it out in full, but we know it's just the same thing again. But the important thing is there that the alternate is it does not follow. So we're going to do a chi-squared goodness of fit test. So statistics and tests, and we want the chi-squared goodness of fit. Now, this will then remind you I need my observed data and expected data, and I also need to write in my degrees of freedom. So I'm going to go back to statistics and edit, and I need to type in my observed and my expected. So my observed data is what they gave me in the question to start with, which is 8, 72, 143, 71, and 6. And then what I expected to happen was what I found out with my normal distribution, and that is the second table of numbers here, 68.9, 148.5, 68.92, and 6.83. So we can now go back to our statistics and our tests. And we have our observed and our expected. We know that there's 4 degrees of freedom. And we can now calculate our final answer. So we can see there that the p-value is 0.950 to 3 significant figures. And we were told that we were conducting the test at a 5% significance level, which is significantly smaller. So the p-value is much bigger, significantly bigger, like a lot bigger than the significance value or than the 0.05. And therefore, we are going to accept the null hypothesis, and therefore the students do follow a normal distribution.